This question is asking about the binomial distribution. And the way you know that it's asking about the binomial distribution is twofold. The first condition that you need to have for binomial is two options, basically. So either right or wrong, or heads or tails. Sometimes they'll ask questions about political leanings, and you might have Liberal and Labor. Or you can even have something like rolling a dice where it's 6 or not 6. So there are two options, and essentially one of them is the desired outcome, and the other one is the not desired outcome. So in the context of this question, the desired outcome is the correct decision. The second thing you need for a binomial distribution is the probability always has to be the same. So the probability of a correct decision must be the same in every case that you consider in this question. Or you could say the probability that one of these jurors says that the decision is, or makes the correct decision, is the same as the probability that the next juror makes the correct decision, and so on. Both of these conditions exist in this question, and therefore this is binomial distribution. So now let's have a look at the specifics. First of all, it says the probability of a correct decision. So we're going to call that P, which is the probability of the desired outcome. That's the probability of the correct decision, which therefore means the probability of an incorrect decision is 1 minus P. So we need to consider the probability is going to be between 0 and 1, or 0 and 100%, and therefore the probability of the other option is 1 minus that. Now we know what our probability of correct and our probability of incorrect decisions are. Let's have a look at part A. Part A, it says, what's the probability a two-person jury will make the correct decision? So part A, these two jurors are working independently of each other. The probability the first one makes a correct decision is P, and the probability the second juror makes a correct decision is also P. So therefore, the probability that both jurors make the correct decision is P squared. Part B asks us about a three-person jury, and there are a couple of ways to do this. One of them is you could draw a tree diagram if you wanted to, remembering that we have our first juror here, which will either be correct or incorrect. Let's call that I. The second juror will be correct or incorrect. And the third juror will be correct or incorrect. And there are my options. Now, for the jury to make a correct decision, it needs 2 correct or 3 correct. So it can have one wrong. So the paths that we could take are all 3 jurors being correct, 2 jurors being correct, and 1 being incorrect. Again, here's correct, incorrect, and correct, and then incorrect, correct, correct. So we can see that there are 4 paths. 3 of these paths are correct, correct, incorrect in one order or another. So there are 3 of them that have these in some order, which means the probability is going to be P times 1 minus P. And one of the paths is all correct, and that's going to be P times P times P. So therefore, the probability that we have 2 or 3, so that's the probability that we have at least 2 people being correct, is going to be P cubed, which is this, plus 3 times P squared 1 minus P. And that's the probability that they're going to be correct. But there is another way we can do this without drawing our tree diagram. And that's by using the formula for binomial distribution that says the probability that x is a given number will equal nx p to the x, and then 1 minus p to the n minus x. Now what this means is here we have an expression that effectively counts how many trees or how many branches there are on a tree diagram. This is the number of correct probabilities, x, and here is the number of incorrect. So in this circumstance, I would say the probability that x is 2, notice how I'm only doing the probability of 2, not the probability of 2 and 3. But the probability of 2 is 3, 2, and then p squared 1 minus p, and then n minus x is 3 minus 2. Now I'm going to go over here and continue. This 3, 2 business, this business of nx, that equals n factorial over x factorial n minus x factorial. And a factorial means, let's say for example 4 factorial. Factorial means 4 times 3 times 2 times 1. So it's the product of this number and all the integers below it to 1. If we're going to substitute that into this now, we will get that probability of x equals 2 will be 3 factorial over 2 factorial 1 factorial times p squared 1 minus p. And 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. So therefore 3 factorial over 2 factorial will be 3. And therefore the probability that x is 2 is going to be 3p squared 1 minus p, which is what we got here. And to that we need to add the probability of 3 correct, which is this. So that confirms 2 different methods. The probability that a 3-person jury will make the correct decision on the first trial is 3p squared 1 minus p plus p cubed. The third part of this question asks us to sketch on a calculator what these 2 distributions would look like, or what these 2 numbers would look like. Here is my probability for 2 jurors getting it right, and here is my probability for 3 jurors getting it right. So let's have a look at the blue line and the red line. And what I would want you to notice here is that throughout the entire patch here between 0 and 1, the red line is above the blue line. So what that tells you is it doesn't matter what the probability of getting the decision correct is. What we know is that because the probability must be between 0 and 1, what we know is in all cases, the red line is above the blue line. In all cases, the red line will give us a better outcome, and therefore in all cases P3 is greater than P2 over my domain between 0 and 1, or at least equal to in the cases of 0 and 1, and therefore 3 jurors is preferable. Now we're going to have a look at the performance of a 4-person jury. That means I have n equaling 4. The number of trials is 4. Now for them to make a correct decision, I need 3 of them to be correct or 4 of them to be correct, because 2 people will make for a hung jury and therefore it would need to be redone, and 0 or 1 would make an incorrect decision. So this is what I'm looking for. Ultimately, I'm looking for the probability that x equals 3 plus the probability that x equals 4. And I'm going to use the formula to do this. The probability that x equals 3 will be n over x, so that's not a fraction, remember, this is this factorial business that I talked about before, by p to the x and 1 minus p to the n minus x, which will be 3 times p cubed and 1 minus p. Now remember, 3, that is 4 times 3 times 2 times 1 over 3 times 2 times 1 times 1. Remember, we get that from n factorial over x factorial and 1 minus, n minus x factorial. So that would be 4 factorial over 3 factorial, 1 factorial. And that's how we got that. One of the things about factorials is we can cancel them down often. And you can see here I've got times 3 times 2. The ones don't make any difference. So that actually equals 4. So this, therefore, equals 4p cubed, 1 minus p. We also know that the probability that x equals 4 means they all get it correct. So it's p multiplied by p, by p, by p, and that is p to the power of 4. So therefore, the probability that the 4-person jury make a correct decision is this plus this. So therefore, my answer will be p to the power of 4 plus 4p cubed 1 minus p. This is another question where I'm asked to sketch these two distributions and have a look at which one's higher. And you can see that for all of the domain between 0 and 1, my red line is now higher. Remembering that a probability must be between 0 and 1, so my p-value must be between 0 and 1. So here's the only relevant stuff. At 0, they're both equal to 0, and at 1, they're both equal to 1. But for all other values, so for x between 0 and 1, or p between 0 and 1, my red line is higher than my green line, which means the red, which represents p3, is higher than p4. So therefore, the preferable is the 3-person jury over a 4-person jury. So now we're going to put it all together and finish the question. Part F asks what the optimal jury size is out of 2, 3 and 4. And we've seen on both of our graphs and in all of our cases that the line that's the highest is 3 people on the jury. So that will be the optimum jury size. Part G asks for what values of p would a 2-person jury be picked over a 4-person, and Part H asks the 4-person over the 2-person. So I've sketched both of these here for you, and what we want to do is find the point of intersection. Because in this lower part of the graph, it might not be easy to see, but the blue line is higher than the green line. Then there's a point where they're equal, and then there's a point after which the green line is higher than the blue line. Now, if you use the solve function on your calculator, you'll be able to find out that this point here is where x equals a third. Remembering that I'm using x for the letter P in this question. So the values of P for which a 2-person jury would be picked over a 4-person jury is when the blues higher because the blue is my P2. And the values of P for a 4-person jury to be picked is when green is higher. So therefore the answer to part G is that P2 is greater than P4 when my p-value is between 0 and 1/3. You may not need to write 0 because it might be understood that a probability value can't be negative, but it's always nice to be really explicit. And then the other side is when green is greater, so when P4 is greater than P2, when P is greater than 1/3, but less than 1. And that'll tell you when you should choose those numbers of people. If you found this video helpful, please subscribe or like. Thanks.